this thing is very important in our daily life. It is hot. It is powerful. Without it, we humans could not be what we are right now. The chemical configuration can be very simple or extremely complex. If you still have not guessed out what it is, it's combustibles. Welcome back to Science Explained with me, Nitrofusion Lite, aka Nitrogen Man. Today, we are taking a look at some very useful combustibles. Now, you might ask, what in the name of glorious Jesus Christ is combustible? Well, a brief explanation is basically things that combust or burn, better known as a flammable, but in a more precise way. It sounds more professional, so you can show off to your family and friends. And then, you must say, isn't that fuel? Well, it is important to notice the difference between a fuel and a combustible material. A fuel is any material that can be made to react with other substances so that it releases energy as heat energy or to be used for work. So it contains radioactive nuclear fuels and nuclear fusion, while a combustible is somewhat a more narrow category, the stuff that burns. Most fuels belong to this category, so the difference can be ignored in daily life. So, after all these definitions, let's actually see some combustibles. The majority of combustibles are hydrocarbons, with the simplest being methane, a gas, and if it goes complex, then things like gasoline, cooking oil, and other complex stuff. These typically have a higher efficiency over other fuels, and currently the majority of hydrocarbon fuel are obtained as a form of fossil fuel or biofuel, plant and animal-based fuels such as wood. Other than these fossil fuels, wood is also an important fuel. It is the most ancient fuel and still in wide use today. In some countries, fuel wood consists more than 70% of the country's total energy output. But if you separate the hydrogen and carbon, you can see that both pure carbon and pure hydrogen can burn. Pure carbon such as coal and charcoal are used as barbecue and coal power plants. Pure hydrogen in cryogenic liquid form is used as a rocket propellant, which will be covered in a future video. And you can see them in lots of rockets, some famous ones being the Space Shuttle, Ariane 5, and the Future Space Launch System, planned by NASA. However, not only hydrocarbons can burn, metals such as magnesium, sodium, and aluminum, especially if grinded into fine powder, also can burn. And these burning metals typically have an ionizing color, such as sodium being yellow, copper being cyan, cobalt being blue, and magnesium being bright white. That's why in the old days magnesium powder, also called flash powder, were used as early camera flashlight. Now, the typical outcome of a completely pure hydrocarbon, like butane, burning in air, is carbon dioxide, carbon monoxide, and water vapor. And if the compound is not pure, it may produce aromatic compounds, cyanides, and greenhouse gases, and other stuff. Okay, it seems like we have finished covering everything coloured in the NFPA 704 fire diamond: reactivity, health, and flammability. Of course, the white box will be covered, but since it's a really broad topic, that video will be a little bit long and will be uploaded later. But I think that wraps up for today's video. Hope you have enjoyed this episode. Make sure to smash that like and subscribe button. And don't forget to turn on the notification bell so you won't miss any more awesome videos of mine. See ya.